Hi, this is Ms. Sigala, and this is the homework for Unit 1.5, where we talked about accuracy and precision. Okay, the first part of your homework asks you to consider the following measurements in the table below. The values were recorded during a lab investigation in which the final mass value of the sample created should have been 26.30 grams. So basically what they're telling us is that we know what our weight should have been. In this case, this is our known value, okay? Or there's another word for it. You can also call it a true value, okay? All right, so then it asks, number 1, accurate and precise. List the students whose measurements were accurate and precise. Well, first we want to see what accuracy and precision means again. So remember, accuracy means how close were we to the actual known value, okay? And so in this case, you want to see our known. We have to know our known, 26.30 grams. And again, we're extending out to the 100th place. So Megan, 26.30, that matches exactly. 26.9, that's pretty close. And 26.30, that's on target as well. Okay, so far we have Megan. Okay, let's look at the rest. Heather's measurement is 28.12. Okay, so in this case, Heather's measurement is not accurate. Okay, she has 1 yes, but her third measurement is way off. Okay, so in this case, she wasn't precise or accurate. Okay. So we go to Luis, same thing with Luis. Measurements are still a little off. Adam, 24 grams. Now if you notice, Adam is missing a 100th place. So again, everybody else goes out to the 100th place and Adam does not. Alright, George. George seems pretty close. Okay, 26.28. 26.31 and 26.32. There isn't a lot of variance, so we can consider George's measurements to be accurate and precise. Because, again, remember, precision means it's extending more significant figures or more points past the decimal point, and it also means repeatability. Okay, so let's look at who's precise but not accurate. So again, precision. Okay, in this case means repeatability. Can repeat their measurement, but again, remember, precision means we have to have more units past the decimal point. And so let's see, Megan, well, we know it's not her because she was both precise and accurate. Heather, no, because her measurements don't show any repeatability. We go to Luis, okay, so we have 36.39, 36.40, and 36.40. Well, those do show precision because, again, his results were repeatable, but they weren't accurate because they're way off from the known or true value. Adam, again, Adam's measurements do not extend past the 100th place, so Adam cannot be considered. And George, again, George we know is already accurate and precise. So in this case, the correct person would be Luis. Neither precise nor accurate. Okay, let me erase all this. Neither precise nor accurate. Well, in this case, we only have one person, and that would be Adam. Because Adam is not close to the known value or to the true value of the measurement. And also, Adam's measurements do not extend to the 100th place like all the other measurements do. Accurate but not precise. Okay, well, someone might have been on target at least maybe once. Okay, and we look at our results. We see Heather was accurate once, but her results were not repeatable. So in this case, that would be Heather. Okay, so we have another question. Jake massed a known 200-gram object and obtained a value of 253.3 grams. Okay. So here's your known. I'm going to underline that so I won't forget. But his value his result was 253.3 grams. He repeated his measurement technique 2 additional times, and his results were 253.8 and 252.9. Were his measurements accurate, precise, or both? Answer and explain. Well, in this case, we know that his results were not accurate. Okay, and that's because we compared the known versus the actual, and so because results were not like the known. Or true value. Were his results precise? Yeah, they're pretty good. So in this case, they were precise. Because of repeatability, and because, again, his measurements extend out to the 10th doubtful digit. Oops. All right. Next part of the homework, it asks us to use X's for data points and draw examples of each description. Okay, so I'm going to draw my little X's. Again, in a bullseye, we know that our target or known value, in order for you to win a game of darts, we want to aim for the center. Okay, so we're going to consider this our known value. Also, when we're doing experiments, we want to make sure that we get as close to our known value because that says a lot about our technique and our equipment. So if we're accurate and precise, our results will be right as a known or our target value, and they're also going to be repeatable. If we're accurate but not precise, okay, maybe one time we get lucky, but other times we're not. If we're precise but not accurate, well, it can be repeatable. Our measurement can be repeatable, but we're not close to our target. If we're not precise and not accurate, then our results are basically all over the place. And something's either wrong with our technique or our equipment.